So let's look at graphs in linear motion. So our first graph is distance time graphs. Now these are graphs of distance against time. That is, when distance is plotted against time on x-axis, then the graph is referred to as distance time graph. Now in this graph, what is important is that the gradient of any distance time graph is equals to speed, or if we have displacement time graph, then the slope or gradient will be velocity. For example, we have a graph given, and in this graph we need to determine the speed of the object. So in our solution, we know that the speed equals to slope or gradient, and this will be change in distance over time taken within that period. So in this case, we can have here the coordinate is 50, 250. Then at the origin we can use 0, 0, so that change in distance becomes 250 minus 0 over change in time will be 50 minus 0, and that gives us 5 meters per second as the speed. Our second graph is velocity time graph. So this is a graph of velocity on the y-axis plotted against time on the x-axis. So it is important to note that the gradient or slope of a velocity time graph is equals to acceleration or retardation, and the area under the graph of velocity time graph gives the total distance covered. For example, in example 3, we have a graph given, and in that graph we are required to find the acceleration, retardation, and distance covered. So in this graph, between P and Q, the object accelerates, and therefore to find acceleration we need to determine the slope of the graph between P and Q. So at Q we have 2, 200 at p 0, 0. So our gradient will be 200 minus 0 over 2 minus 0, and that is 100. And therefore, the acceleration is 100 meters per square second. Between R and S, the object decelerates, and therefore to calculate retardation, which is simply negative of acceleration, the change at R we have 6, 200, and at S we have 10, 0. So the retardation is simply equals to negative of acceleration, and in this case our acceleration will be change in y over change in x, and that would be 200 minus 0 over 6 minus 10. So that would give us 50 meters per square second. Now the total distance equals to area under the graph, and since the graph is in form or in the shape of a trapezium, we find half of 10. So the upper is 10. The longer length here is 10. The upper part here is 4 seconds. So we have 10 plus 4 times 200. The height is 200. So that would be a half of 10 plus 4 times 200. We get 1400 meters as the distance covered.